in this video, I'm going to demonstrate how to do the setup for game 4 from Prep Test 63. This one is a little bit unusual, so let's take our time with it. So we've got 6 positions, let's say, okay, and these positions are going to be vertical rather than horizontal. So there is a sequencing element to this game, but it's unusual because these positions are vertical, not horizontal. They're also a bit odd because we actually are numbering them from 1 to 6, with the lowest one being number 1 and the highest one being number 6. Okay, so those things make it kind of not intuitive, I would say. Okay, and then we have 1 player per position, but we only have 3 categories for the players, and those categories we're going to label G, R, and W. Okay, but we are going to have a player in each position, and we don't know how many from each category we're going to get. So that's what we start off with. Okay, so I'm kind of speaking generally here, but yeah, those are our main rules for the diagram that we get from the little blurb at the beginning, and then we get rules. So the first rule tells me that I get more from the red category than from the white category, which is W. So the number of R's is going to be greater than the number of W's. Okay. There's a position where we would have G lower than all of the R's. Okay, so there's going to be at least 1 G, okay, lower than any R. Okay. So now that I know that I have a minimum of 1 G, let's say I only have that one G, okay, and then I have to have more red than white. Well, then I could have 3 red and 2 white. Right? We could make that happen. Okay, so that seems to be one option for how I would distribute or how I would pull players from the different categories, right? So that does seem to be an option, but likely not the only one. If I had 2 green, I could have 3 red and 1 white. Okay, so they're colors, right? Those are the categories. They're just colors. I'm gonna stop trying to speak in general terms with that. We know they're colors. Okay, so so we could have 2 green, 3 red, and 1 white, or we could have 3 green potentially, 2 red, and 1 white. Okay, so I'm just seeing what are the various options here. Looks like it's also possible that we could have 1 green, 4 red, and 1 white at this point, right? Okay, and then 3. There's a white ball in a box that is immediately below a box that contains a green ball. So white immediately below green. So this exact combination happens a minimum of once. Okay, so there is a white ball in a box that is immediately below a box that contains a green ball. So this has to happen. And we don't know that there's exactly one combination like that, just that there's a combination like this. The reason we can't have that twice would be because we can't have 2 green and 2 white, because then we would only have 2 red, and red can't have the same number in the diagram. So this one's not going to work, but not because of rule 3, but rather because of rule 1. Okay, so that's the setup. I would say just kind of give it another try with the setup like this and see if it goes a little bit easier. See if maybe there was a rule that you misinterpreted. Something to note as well here is that there is a box containing a green ball that is lower in the stack than any box that contains red. So there's a minimum of 1 green before we have any red. Okay, so we can't have red at the very bottom, that's for sure, right? So we could have green there, and then red, 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 then white, green. That's an option. So sometimes with a bit of a weird game, before I get into the questions, I might actually kind of just come up with some scenarios that would fit with the rules. So like G, R, 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 and GW like that. And we also know that this isn't a minimum of 1. It's exactly 1. It's also a maximum of 1, right? Because it can't happen twice. So if the minimum is 1 and the maximum is 1, that just means that it happens exactly once. Okay. But yeah, this is an option. But it's also possible that we have green, red, red, red. No problem with that. And both of these so far are situations where we have 2 green, 3 red, and 1 white. The first question, question 18, asks if there are exactly 2 white balls, then which one of the following boxes could contain a green ball? So 2 white balls means that we need to have 3 red, which means there's only 1 green. So that green has to be in the white green group, and it has to be before any of the red. There are 3 reds. Okay. So we know this orientation, but there's an extra white that has to be placed. And so that white ball could really go anywhere here. There's no restriction on where it could go. Okay, so this is our lineup, but we can put a white one in there at any point. So if we put the white one on top of the green, then the green would be box 2, right? If we put the white below the green, then the green would be box 3. Okay. So we would have, so here's white, green, white, red, 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 green, white, white. Okay, so we're being asked about which boxes could contain the green ball, so we're really just focused on how could the position of the green ball change. So it could be 2 or 3, and B says box 3. So that's the correct answer for question 18. Okay, so try the rest on your own and let me know if there are any specific questions that you'd like me to review.